This is Programming Chapter 5, Part 3. We're going to be looking at converting strings into numbers because it's an important concept. Whenever you enter numbers, it's actually text, and we need to convert it to integers or floats. So let's look at the exercise to see how we do this. So we enter a decimal value, we read it as a string, and then we're going to do this string to int function. And string to int is here. So the best way to do this is to actually set a breakpoint. And we're just going to run it. Okay, we're going to enter an easy number so we can see all the different digits. Okay, so we've entered 1, 2, 3, 4. If we look at this, we see the ASCII codes for 1, 2, 3, 4. This is 49, 50, 51, 52. So let's step through the code a bit. We initialize number to 0, and we initialize I to 0 as well. We're going to look for the null terminator. If there isn't one, we continue with the code in here. So the first one is not a null terminator. And we're checking to see if it's actually a digit. So it has to be between ASCII code 48 and ASCII code 57 inclusively. So that's true. So we take number multiplied by 10, and we're adding the ASCII code minus ASCII code 0. So this one's a 49. We're subtracting a 48. That gives us 1. So we're converting ASCII code 1 into an actual integer 1. We're starting with the highest digit, and we keep multiplying by 10 and adding the next digit. So we have 1. Now we increment the index. We go on to the next character. The next character is a 2. So we're taking 1 and we're multiplying it by 10. And then we're going to add value 2 rather than the ASCII code 2. And this gives us 12. Now we get the next digit. It's ASCII code 3. So that's value 51, or ASCII code 51. We're subtracting 48. So 51 minus 48 is 3. So we're multiplying the num by 10, so that'll give us 120. When we add 3, it'll give us 123. So you should recognize the pattern, and the next time we're going to multiply 123 by 10. That'll give us 1,230, and then we're going to add the value 4. So you can see that converting text into an actual integer value takes a little bit of work. And here, when we do a %d, it's actually converting the integer value into text. So if we look at our output, we see text, but we've calculated the actual integer value and stored it into memory. So a little bit about the logic here. We're multiplying by 10 because the decimal system is base 10. If you want to convert it into a different base, you have to multiply by whatever the base is. And you have to check to make sure the input is within the base. So if we have base 10, we only accept digits 0 to 9. If we had base 8, we would only accept digits from 0 to 7. So exercise 5.8. Given what I've told you, you should be able to convert a string that contains a binary number into an integer. So you might want to call this function binary string to integer. And here's sample printout. So you should try these values. If you try this value, you should get 91. If you try this binary value, you should get 819. And that completes this lesson for Chapter 5. When you're done, proceed to Chapter 6.